Hi, everybody. This is Kubernetes SIG architecture meeting for April 30th. I'll share the agenda. We have two items here, unless some of the other folks are here as well. These have been on the list for a long time, so happy to talk about them if we have time. But for now, Radisson, I can. Do you want to share anything, or do you just want to discuss it? I can give you host. That's what I'm.
Yeah, it might be useful. I have a few slides that
Okay.
we discussed. Yeah.
Okay. You are able to share now. I'll stop sharing.
So in the checkpoint restore working group, we have been discussing um, how to enable pod level checkpoint restore, and we so far we have achieved consensus on the checkpointing mechanism that uh, we were trying to define both the CRI APIs and the um, um, essentially the APIs that allow us to trigger um, for users to trigger the checkpointing mechanism. And the main question that we're trying to essentially that is blocking us and we're trying to answer right now because we're targeting 137 release, and we essentially we need some guidance and advice on what would be the best approach is mainly for the restore API. So we have essentially two main options. The first option is to extend only the pod specification with a new restore from field that will essentially specify the a reference to a checkpoint. Um, and this will essentially follow the same path with creating a pod. So for example, if a user wants to restore a pod from a checkpoint, they will just specify this restore from field into the pod specification, and this will restore the pod itself. The challenge here, we discussed this in the API machinery um, meeting about a month ago, and the feedback we received was to essentially use the volume snapshot mechanism as precedence and to um, essentially explore whether we need to separate the security permissions for creating a pod and restoring a pod from a checkpoint from a snapshot. And the main challenge here is that we um, because snapshots can contain sensitive data, for example, user data or passwords or secrets, we want to be able to use different permissions for creating a pod and restoring a pod from a snapshot. And the main essentially feedback we received so far was to essentially come to this meeting and discuss what would be the best approach. And I'm sure Peter can also expand on this and what are the pros and cons with both approaches. Peter,
Yeah. Basically, the way that I see it is I feel like the pod field is going to be needed regardless because even in the case of having a separate restore API, we need some way to tell the kubelet like this pod is not coming from the images. We're not going to create a new one, but we're going to do some restoring. So that reason alone makes me feel as though the pod level field alone should be the approach. I think the external object, it's a little bit confusing what the life cycle of the pod restore object would be because like after the pod is actually created. To me, they're more tied together. A reason to have the checkpoint be a separate object is because the life cycle of a checkpointed of like that snapshot is going to be separate from the underlying pod. Like you can delete the pod, but still have the checkpoint archive and then restore it later. but there's not really like a reason to have a restore object outside of the existence of a pod that it was restored into. On the and then there, at the API machinery, one sort of question that we brought up and is like whether there is precedent to have a different permission structure to edit a field within an object versus edit the other fields in the object. So because we can imagine a world in which a cluster admin would want to limit the number of people who can restore a pod, but not limit the number of who can create a pod, right? But if we had a specific field in the pod object, then we would have to have slightly different permission structure for that. Jordan mentioned that there is some precedent for that. I forget what the precedent was in this moment, but it is not, maybe he didn't seem super stoked to follow that precedent again, but it seemed possible. And I think either because we're admitting to the world where there is a pod spec field either way, I think we would need this either way, which makes me feel like the extra restore object is redundant.
We also need permissions not only for restoring from a snapshot, but also which snapshots a user can restore from, I guess, in more extent.
And that piece of it can be controlled by the checkpoint controller, which is ultimately going to be responsible for creating the checkpoints. So that piece of it will be a little bit easier because there is this external object that we can, enact RBAC permissions on.
Tim, do you have your hand?
Yeah. So historically, there's really only two ways to govern sub object access. One is sub resources, which have a lot of detrimental effects on client generation. So we've sort of been wary to overuse those. The other is this proposal made by one Daniel Smith to add field level RBAC, which was sufficiently complicated that it kind of went nowhere. It would need some significant attention to get it up and running. It's the right way to do it, in my opinion, but it's not a thing that exists. So there isn't really a great answer for field level access. Okay, so Justin says we could use VAP. Yeah, kind of. VAP is pretty limited, I think, for that. But the question that I had was really about the thing you touched on last, which is permissions. Who's allowed to restore from which checkpoints? Where are they stored, et cetera? And I'll also draw one analogy. There's only one other place that I know of in the system that does a similar pattern here, which is volume snapshot restore. And they do it a different way. They have the field inside the volume, and I kind of hate it, honestly. I kind of prefer this approach where a pod restore is a declarative request for an imperative thing, because I think it's the more recoverable pattern, but it is different than what we've done in the past.
So my question was, I think what Tim brought up, that if you control access to the snapshots, why do you care who can restore, as long as they can only restore from snapshots to which they have access? I'm not clear on what the vulnerability is there if they don't have access to the snapshots.
That's a great question, and that's something that is actively occurring to me in this moment. I think one reason is a sufficiently unprivileged user. A restore is a pretty expensive operation, especially if you're restoring any sort of extra external, a GPU restore to pull stuff into GPU memory is going to take a bunch of time.
Sure, but if they can create a pod that can do whatever, they can create an expensive
absolutely
thing. Yeah.
I think that is definitely a relevant path of consideration, and I don't off the top of my head know of exactly what the limitations would be, but I think that could possibly work, of just treating the the access to the checkpoint object as the gate to do the restore.
Okay.
I guess we have different use cases as well, and one of the use cases accelerating the startup time of, for example, inference workloads for agentic AI, for example, and the other use cases when we use checkpoints as a fault tolerance mechanism, for example, for training workloads. And the main challenge here is that once you create a snapshot, it contains a copy of all memory pages of the processes running inside. So if you have access to the checkpoint, you can essentially extract data, essentially any data stored in memory. And with essentially the idea with creating a snapshot object was to be able for users to select which checkpoints to be restored from. So I'm not sure where exactly. I think your question is correct, but it also depends on the use case.
I think Rediston, the operative piece of that you mentioned is like the access to the checkpoint is the security hole, right? So because we have this external object, we've decided that the external checkpoint object that's going to exist. I think what John is suggesting is that that's the gate that we use to dictate what who has access to the restore. Just the same as you should be gating non-trusted users from just reading the checkpoint archive, because that has all the memory pages and everything. So I think that is actually a pretty elegant answer to the question. I'm sure that there are some folks who have some thoughts. I think in the queue next is Sergey.
Yeah. My question is mostly about use case and how, like, even with permissions here and there, like, do we envision scenarios when pod is scheduled by controller, but depending on where it lands, like if it lands on the same environment where a checkpoint was taken, checkpoint will be used. Alternatively, it will start as usual because environment doesn't match. Or maybe you have multiple checkpoints associated for different environments and it being picked up at comparing to where it lands somehow. Like, do we envision like when create operation and checkpoint operation have the same? I mean, it's basically the same operation, just depending on when it lands, it will decide how it will start.
So this is an interesting question. I don't feel like we've. Oh, sorry, Rediston. I don't feel like we've concretely thought through this, but
I can add something here. I think it's not exactly the same because, for example, when we create a checkpoint of application that uses GPU, for example, NVIDIA driver, we have to restore with the exact same driver version. So when we do scheduling, for example, we don't select nodes based on the driver version that they use, but when we restore from checkpoints, we have to validate also the driver version. And there are other requirements like the CPU that is being used. For example, if we checkpoint on a CPU that supports certain instruction, we have to restore on the same CPU, or otherwise the restore might fail. I think these are the main limitations.
So, and building off of that a little bit, to be clear, our initial implementation is not trying to solve node migration right now. So right now we're expecting the node to stay the same for a restore. We're imagining what it will look like to do that. And I think our answer for that is having this checkpoint controller be the entity that's moving these things around. So I can imagine, Sergey, for your use case, which is super way down the line, not really, we're not going to be thinking about it for a while, but we could answer that question by basically a user, it says like, okay, I want to restore this pod or create it if it's not present on the node that it gets scheduled to. Scheduler does its scheduler thing, selects the node name. At that point, the checkpoint controller looks at basically where the node that was selected and decides whether or not the checkpoint, it should be coming from a restore, and then it modifies the restore from field in the pod spec before that goes ultimately to the kubelet. And then the kubelet is like, oh, I'm either restoring or not, depending on what the checkpoint controller said. I can see, like, obviously that's like a hand wavy answer, but like, I can see that fitting within the construct. But a short answer to your question is, I don't think we've thought of that. It's, to me, something that we're punting down the line because node migration is complicated for the reasons Radisson was talking about. And so it's not something I have a great answer for yet, but like I want the API that we designed to be able to accommodate that maybe one day in the future.
Yeah, that was my point, to make sure we are not locking ourselves into the specific human-driven or like controller-driven scheduling or restoring.
Yeah. I think next was Mo.
Yeah, I'll be quick. So I'm not stating that you need a particular design. I just wanted to mention in regards to field level authorization, like we do have a pattern within like the pod certificates API and various bits of like the DRA API, as well as the CSR API, where setting certain fields causes secondary authorization checks to be done. So like basically like, can you do this thing in this particular shape? That's handled, and that can also be externalized through VAP, because VAP can also make those secondary authorization checks based on certain fields and certain shapes. So that pattern does exist. We don't need like Daniel's field level authorization cap. We already have a pattern. If you need it, it exists.
Probably not to need it, right? So everything we've ever done that was based on does the user have permission to do X has aged really poorly, right? Because what happens is you have a system that seems to work, you go to automate it, it doesn't work anymore. Or you have something that works for David and he hands his stuff off to Mo and it doesn't run anymore. If you have an ACL boundary that isn't based on that, that's based on something like the powers of the service account, or which I also would suggest against, or if it's in the same namespace, you can use it, that ends up being a lot more practical because things become portable. Does that make sense?
Are you talking about like the whole like pain points in regards to like security context constraints and stuff like that, David? Like where
Yeah, that's the one that it really stands out as, if the user's allowed to do this, we'll allow it. And
yeah, so I want to be clear, that's not what I'm stating though, right?
okay.
I'm the secondary authorization check I'm talking about is in sort of the context of the resource itself, right? So for example, for a pod, the secondary authorization check could be on the service account the user created the pod.
It could be like finding a way to say like, yeah, whatever pod checkpoint objects exist in this namespace, you can use them, is I think would ultimately be easier to understand.
Yeah, and that's also fine, right? That's more similar to the node authorizers, like and you reach this, if so, that's fine. That is, I think, totally valid too. But to me, all of those are patterns, existing patterns of secondary authorization checks, whether they're directly called the SAR API.
Okay.
Well, I'm mostly trying to make sure that we don't think that we don't have any path forward without like trying to revive Daniel's check. I do think we have plenty of paths forward.
I think Justin next.
I'm not sure it was me, but I actually don't know who's next. I'm actually wondering whether we need a separate field on pod. What is the difference between a checkpoint and an image that embeds that checkpoint type thing?
Well,
and if we,
yeah. This is actually a strategic change that we're actively making. And like, I think we're a little bit figuring out what the checkpoint object is going to look like in the API. But so with forensic level checkpointing that has existed for a handful of releases, we went through image name in sort of like a hand wavy, like the container runtime will interpret an annotation on the image and then like, oh, I see that it's a checkpoint archive. I'm going to restore it instead of create the container the normal way. I want to move away from that pattern. I find it sort of like it traps us, and it also is like the Kubernetes world is less aware of it than I think that like it should be. So I don't actually think that we're going to be having like individual, like, I think I can imagine a world where we don't have individual container level checkpointing. We only have pod level checkpointing. That's only going to be coming from this checkpoint like object that we have in API that's controlled by this checkpoint controller. Because that gives us the benefits basically.
This is also something that we are currently discussing because there is a new proposal for dynamic pods where essentially containers are being added and removed from pods, and container snapshots might be useful in this case. But just to answer your question, we don't have an image field for pods, and we're trying to create a pod snapshot, essentially a snapshot that contains all containers inside a pod. I think.
Yeah, I think my current vision is that like, and this I think we agreed, we are actively debating. My current vision with it is that like a pod to restore a pod checkpoint, you're gonna have to do the whole thing as it's checkpointed, and then maybe eventually you can edit the containers outside of that, like thinking about the dynamic pods case.
And
that's emerging.
This is also because we have shared resources. For example, if we have volumes or other shared memory between multiple containers, the only way we can create a consistent snapshot is to capture the whole.
Yeah, exactly. Tim, bring up the queue.
So I have now like 3 questions to ask. Sorry. The usage, I apologize, I have not read any of the KEP work on this. Is the usage pattern like you spin something up, take a sort of golden snapshot, and then you use that as an accelerated start path? Or is it to provide like a virtually long running pod that sometimes isn't actually running, but it still kind of exists?
Yes.
Both are.
Yeah. We have also third use case, but essentially one, for example, with inference workloads, if you initialize VLM, it takes us a few minutes to essentially load the model weights and to initialize the inference engine. And the idea is to create a snapshot once the inference engine is already initialized and ready to serve requests. And then starting from this snapshot takes a few seconds. So it's significantly faster. And it's already being used in, for example, NVIDIA's Dynamo and a few other, for example, serverless platforms that use inference workloads. But for example, we have a use case where people want to resize to change the resources of pods, and they can create a snapshot of the containers that are running inside, resize the pod, and then resume the execution from this snapshot. And the other use case is when we want to preempt, for example, job sets that is being, for example, when we have jobs with different priority and we want to preempt lower priority jobs, we can use the snapshot to essentially preserve the current state. Peter,
so you got to my next question, which was just to clarify, if a pod snapshot is a pod, so it's got multiple containers and it's got all the data that it needs for those containers, and maybe there's some empty DIRs that go between it, and does the snapshot include like all file system state or just memory state? And B, if all that is sort of baked into the snapshot, what is the point of having a pod spec that says restore from this snapshot if the pod spec can't actually deviate from the embedded spec? Like would it be reasonable to make a pod with one container that says restore snapshot, and that snapshot has 5 containers? What does that mean?
Yeah, and I think that, so sorry, I've already forgotten your first question, but the answer to your second question is, I think the plan is to have to save the pod spec and status in the checkpoint object, either on a file on disk in the archive or in the API object. We're figuring that out. And then make sure that they're the same, basically. That is the current plan, with potentially one day modifications, like selected modifications, like maybe you can change the pod name, or maybe you can change the namespace or things like that. But because for the reason that you're asking, which is like, what does it mean when the archive and the existing pod spec differ? And I think we want to be really intentional about the ways that we allow that to happen. And so to start, we're going to have no ways of difference, and then like eventually build out on top. I think is the current approach.
The first part was, what about like on disk state, like empty dirs?
Yes,
Right.
So essentially, what we do is in the container runtime does diff based on the, essentially we create a copy of the read-write layer of the container, and we include this in the checkpoint. So when we restore, we use the same base image to essentially create the file system, and then we apply the diff. So this is the file system change.
It's
Okay.
both disk and memory, and then we save the in-memory state and save that as well, and restore that.
Okay, that's reasonable. One more question, then I'll cede the floor. One of the things I've been hearing from a lot of customers recently is, I want to run very big number of things in my cluster, right? I mean, agents are obviously a thing that people are dealing with. Agents are idle most of the time. I want to run 5 million agents in my cluster, but only 0.0000001% of them are actually running at any given moment in time. But that requires a control plane that could represent 5 million things. So could you actually represent 5 million pod snapshots here?
It is similarly limited by like etcd limits, because we have a checkpoint archive per pod that we have, or checkpoint object per pod that we have checkpointed. But
that's what I assumed.
Yeah, so it's going to be no different from the API's perspective, and I think that is correct. Though I'm open to hearing differing opinions, but there it is the intention. One of the use cases is the sort of I forget what we're calling it, but basically like that use case where the warm start, where you have like your application that's like ready, but it's not running until you actually need it, like in a serverless case or something like that, and then you can restore it, which would go much faster. That would help for your use case, minus the API limits, which exist anyway.
Yes, I think this is what Tim is referring to as the golden snapshot, that essentially you can restore many times. And one of the challenges here is that we have to change the pod UID for every restore, and for example, IP address and for example, secrets and other things. But this is essentially something that we're going to explore later on.
So my question is, how does this integrate with the workload controllers? Like in the case you just talked about, right? What I really want is for the workload controller to kind of not even know, right? It's like, oh, I need a new pod, and it starts throwing out new pods, and it just so happens that some of those can be restored from this golden checkpoint. Like, what is your vision for that? I know it's early, right? But like, I'm trying to understand. Like, if you have a separate pod restore object that you have to create, that means every workload controller now needs to understand pod restore, right? Whereas if it's field,
I think every controller will need to be aware of it. My goal is that the end user who's creating the workloads don't necessarily, but so my vision is, and we're sort of molding this actively, but I think basically at every level that we have a workload, they would also have a checkpoint style object for that workload. Totally not positive that like originally we were thinking, oh, we'll have it be checkpoint be a sub resource, and then every additional workload could have another checkpoint sub resource, but that's not happening anymore. So now we need a new object basically. But the goal would be that a user can say like, I want to checkpoint this leader worker set, and then the leader worker set controller goes and enacts that checkpoint for all of its individual, like it bubbles all the way down the stack basically until it gets to the pod, and then the pods are checkpointed and those objects are stored. And then if a user, and then it would be up to the checkpoint controller either to expose the API in the same way, like restore from, as we do with vanilla pods, or to do it opaquely in the background, where like a user has, spun up another instance of this. Oh, I see. I have the warm started leader worker set that I checkpointed. As the controller, I'm going to do that. I would say we should leave up to the controllers to decide on like what they would do best. But the pattern is probably going to look similar for every like level of the stack, is my current vision, and I'm open to debate about that I'm not feeling so positive yet.
Okay, I mean, I think we'll learn over time. I just know, like, as soon as you have to make a change to every workload controller, it's a substantial effort, right? It's like with the workload aware scheduling pieces, right? We've tried to
Absolutely.
minimize the amount, but so it's a challenge just to keep in mind.
And I'm open to like ways you can imagine that we could not have to do that, but like because we're imagining at minimum a pod spec field change, like I guess the checkpoint controller could be watching all pods updated and then like inject them or from in a smart way, but that would be tricky, I think.
A pod spec change, right? Like a pod spec change actually automatically folds into the controllers when they rebuild with the new template. So actually, if all you change is the pod spec, you may not need to change the workload controller itself, other than like it gets built with the next version and it appears in the pod template. And now when it creates that pod, since it's using still a pod creation API, it's using the same API, it just has a new field on it, then it will automatically do it. Now the user has to be able to set that checkpoint. You probably need policies about when the checkpoint was taken. Rather than this explicit checkpoint, it might need to be like last checkpoint, or I don't know what that looks like, that field in the pod spec looks like. But that's like, if it's a separate object, now it's a separate API that the workload controller has to made it, a conscious change has to be made to it. That's my point.
Yeah, no, that's a good point. I think so. The breaking down the two cases, like I think I can imagine in the same way as we have separate object for checkpoint, same object for restore. I think we want that for the different workloads as well. Like I think a workload author should be able to say like, I want to checkpoint my leader worker set on this periodic basis, and then we do that. The controller manages that. But on the restore side, like they should be able to set the intention, like, I wish for this to be a restore if possible. Give me latest, give me this specific one, the details that get figured out, and then that gets actuated on their behalf. So I think the answer to your question is probably there will need to be workload controller changes, at least for the checkpoint side. Maybe we can avoid it on the restore, especially if we're clever about how we handle pod templates. But I do definitely think
that you can checkpoint based on labels, then you don't necessarily need it, right? Like we can identify the pods. I mean, it depends on if you need it to be consistent across all of them. I don't even know how you do that, right? Because I don't know how you'd synchronize across all the pods, right?
That's a piece that is an open question. There's a way to do that in Cryo right now, but like because we want to allow different checkpointing implementations, we're going to have to figure out how to generalize that. But that is something that is possible technically. We just have to figure out what the API looks like for that.
We have essentially two main methods for checkpointing. One is the gvisor runtime, which implements its own checkpointing mechanism, and the Creo project checkpoint restore in user space, which is integrated with runC. And essentially, we can synchronize. We have a mechanism for synchronizing Creo instances, so we can synchronize the checkpointing operation across multiple containers, but we don't have the same mechanism for gvisor yet. And the other problem we are trying to solve is when we have, for example, GPUs and NICO communication between GPUs that we need to abort and then restore. So we are collaborating with a team at NVIDIA that is working on this, and there was one question about ephemeral containers. I think this is currently out of scope, so we're focusing. Peter, do you want to cover this?
Yep. The initial scope. So we've listed this out in the KEP, but we're trying to pare down as much as possible because it's already a complex problem. So no init containers have to have finished running. No ephemeral containers in the pod. We have to decide about sidecars. Haven't figured that out yet. And those are the limitations on the container type as of today.
Okay, really interesting discussion. We've used up 40 minutes almost. We have one other item on the agenda. So I guess last call for questions on this. Have you gotten what you need? I mean, I don't know that we gave you a direct answer, but
I feel like, I mean, throw stones at me if I'm wrong. It sounded like like the separate restore object seems not necessary to start. Like we want the pod spec field for the restore. We're keeping the separate object for the checkpoint. It sounds like all of the questions are sort of pointing in that direction. We do still have the open question of like the like subfield validation, but maybe we just use access to the checkpoint archive and checkpoint object as that gate to start. All of that seems within line. I see David just unmuted, so maybe he's going to throw a stone.
Yeah, I was gonna say, I think it's really important that you don't use the phrase to start. Once you choose the API, that's the API. There isn't a, oh, I'm gonna change it now. So when you say to start, it really needs to be forever, right? Imagine if we add a field to pod spec, like we're not gonna, taking that field back would be a huge decision, right?
Yeah.
I mean, in alpha you can do, but it's not ideal in the V1 APIs. The thing I would ask you to think about is that we have some really different usage patterns here. Like the usage pattern of Golden Master is really different than the usage pattern some of the other ones we described. So like, I'm not sure that one API is going to cover them all. Like you might need, I mean, you might need to just think about like whether you limit scope to one of them and or see if the API. I don't know. I just think through all of them in that way, I guess is my point.
Yeah, that's our intention. And David, to your point, just quickly, all of the things that we're talking about doing just to start provide the baseline for all of the future extensions. So all of the things like maybe we'll relax validation in the future, or maybe we'll add additional APIs. But like I agree, like our intention is like this API that we're doing is going to be the one, and that's why we're debating so much about what the shape of it is.
Okay,
And
as long as that's
John,
clear, I'll say other things that are basically impossible to change, security posture, right?
Totally.
It's very hard to put that back in the bag. So to start again means to be forever. Validation is not necessarily forever, but changing it has consequences. So, you know,
heard.
that's
Yeah,
also like you really want this to be fully fleshed out.
Yeah, and that's our intention to bring in 137 alpha, which is part of why we're optimizing out some cases that like can be extended in the future, with the intention of having the baseline be designed in such a way that it can accommodate those. So all of that, totally hear you, and that is the goal.
Just to clarify about the restore request, whether this should be a separate object or it should be essentially modification to the pod spec.
I think the consensus is modification of the pod spec, and not the separate object.
I think in the case of the Golden Master, that makes a lot of sense. In Sergey's case of like this restart thing, I'm not entirely sure. Like that's what I meant by like let's think through and make sure that
Yeah,
we don't
I think
cut off
having a checkpoint
use
controller
cases. Yeah.
be the entity that is gating this field and like modifying it and ultimately passing it to the kubelet, I think will give us the answer to those questions. But I think we need to figure out, we need to like talk through the exact sequence. But I do, yeah, we'll definitely come, to consensus about that before the 137 cycle, or if we're going to merge anything there.
Okay, awesome. Thank you all. PJ, you're up. You need you want to share anything?
For me to discuss this, just want to give some context. I work in SIG security on a bunch of different things. I also probably joining in a while. I haven't joined in a while, the SIG architecture meeting. So I am my day job is in Broadcom as a security engineer, and with that context, I wanted to share a KEP that some of us in SIG security have been working on. I'll maybe start sharing screen with the draft. I sent the link in the chat as well for anyone who couldn't make it to the meeting. So this is the document. Can everyone see the Google Doc? Okay, cool.
Yes.
So this is basically following the Markdown template, but for easier pre-discussions before it's in a pull request, draft pull request format. We wanted to start putting it out here. It's too long to go through in the remaining 15, 16 minutes. I wanted to get some feedback on 2 or 3 main points that are relevant to the SIG. So for context, the KEP is about publishing program readable or machine readable artifacts, which can be anything, but we are picking VEX as the format for that. That will tell us and everyone who uses Kubernetes whether a specific CVE, especially in Go module, that shows up in a scanner for a per end user, but actually does not impact Kubernetes for vast majority of the times. And these are the requests we keep getting since many years on issues and PRs asking for feedback. This is also not really tied to what Kubernetes SRC does, which is actual Kubernetes affect CVs that affect Kubernetes, and then we figure out who gets to fix this. This will be for everything else that people think Kubernetes is affected, but is really not. And today there is no way to share that information apart from pinning or linking a comment by some maintainer saying, well, we don't use this vulnerable code, or this is not in our Kubernetes threat model, so it doesn't impact us, so on and so forth. So few things I wanted to get some attention on are mainly user stories at a high level, and then we can go into technical deep dives based on that as people learn more. Many folks in the sub project in SIG architecture I know, which is the K8's code organization, work on figuring many of these things out already. They answer majority of the questions as well. I was hoping to actually go into the sub project meeting, but didn't see it anymore in the community calendar. So I thought I'll show up here and you can point me to the sub project meeting if it exists. So first user story I think I just described. We want as some sort of a VEX document that is consumable, where it is located, whether it's in the GitHub repo of KK, for example, as a .vex folder, or is it some place that gets shipped alongside the Kubernetes images? So there are a couple of options there that are described. I would love some feedback there. And then I had two or three other user stories, but I spoke a lot. I'll take a pause, see if there are any high level questions I can answer.
I think most of the folks from that sub project are not here today. Oh, sorry, Justin, I didn't see your hand. I'll go ahead.
I mean, I guess as I understand it, the hope is that by publishing these VEX documents, we will be able to tell people not to worry about the security vulnerabilities that their scanners come up with.
Yep.
The reason those scanners come up with all those false positives, as I understand it, is because if one vendor has 100 and the other one vulnerabilities, the other one has 50, then obviously I want to spend the same amount of money to get 100 vulnerabilities because I'm getting more for my money, right? Are we actually going to solve the problem, or are we just going to be like the customer that paid their money for that like over scanner is going to come to us and we're going to say, no, you have to look at our VEX docs, and they're going to be like, but my scanner says this just the same. Like, how are we actually going to, is it actually have the vendors agreed to like stop false flagging, as it were?
Right. It's definitely important question. I guess there are two aspects to this. One is scanners need to support the format of the documents we will generate, which in this case is VEX. So for example, Trivi has very good support for VEX today, where you can essentially feed it a doc, either it's in their VEX hub or it's local, and you can filter that out automatically. Do all scanners support that? No. Do many scanners support that? We don't have exact numbers, but yes, I would rather pick an industry standard versus like some sort of Kubernetes specific format that then everyone has to adopt. So that was one part. And the second piece is the hope is as this gets more socialized and a thing that Kubernetes community does, people will change their behavior, which is maybe a big ask of opening an issue, saying like, I need to know when this is getting fixed, and instead go and check the Vex document and see like, oh, people already did some work here. I know the answer. Let me not bother the maintainers, and hopefully all of us save time as maintainers. So that's kind of where we're coming from.
So my question was just, so these files, this is like, who makes the determination? It's like basically it's the content of these files is created by us based upon us getting the CVE, going in and investigating and saying, oh no, we actually don't use that particular part of that Go module that's vulnerable, and so therefore Kubernetes is not vulnerable, even though the dependency is vulnerable. Like, is that the process? So it's like almost a, I mean, I guess that could be automated with AI, but essentially it's like right now we get those reports over and over because the scanners just keep flagging them, and we want a single place kind of source of truth to say, yeah, we've already looked at that vulnerability and we've already determined we're not vulnerable, and don't bug us again. Is that the basic idea?
Yeah, that I would also summarize it similarly, like you
Okay.
mentioned.
Okay,
And
that sounds useful.
yeah, and before we go to Ben, I also wanted to share like there is also some responsibility we are taking by authoritatively saying in a document versus a comment issue that this is not impacting us. So there has to be some sort of a equivalent of a PR review process for this, where one or two maintainers maybe get to confirm this is actually true. And then the flip side to that is, are we then increasing the workload for all the maintainers if we make people do the PR reviews for something like this? And the other part is like fighting AI with AI, where AI might end up creating way more CVEs in the future. Who knows? And then this will be 10 times bigger, and can then we use AI to assess whether this CV affects us, auto-generate the report, which is generally hopefully correct, and then the PR review process is sort of almost a no-op in the future. So those are some future considerations to make, and then I'll go to Ben.
I think those are important questions. If I understand correctly, I think we could actually get a pretty big win to start by just making sure we're running symbol-aware source code scanning and then publishing refutation based on that, which we can kind of just let the deterministic machinery decide, and we don't really need a human to approve it. And like that might let us bootstrap some of this without with more time to nail down, like, you know, is SRC gonna approve these, or who's gonna approve the manual interventions, and how does that work? The concern I have is that to begin with, we need to publish these because people are running scanners that aren't putting in like the extra effort to go match it to source code and then do symbol aware scanning. Like almost all of these that I've seen, I can't even think of one where we weren't able to just walk the symbols and go, no, this doesn't, we don't use this symbol in production. Um, are How do we know? How do we publish this in a way that it will be discovered and actually read by those same scanners that are causing this noise? Like if, you know, if we toss it in the repo and they're walking back to like the source repo, couldn't they have done the scanning themselves? Like how, is there some standard for this where a binary will signal where you go look for this info? And if not, how do we make sure that they'll adopt this?
Oh, I see what you mean. Yeah, so let me see if I can summarize the question and then continue to discuss that. So you're saying today we can do symbol checking and figure out based on that all pretty much deterministically whether something affects us or not. And that will be a big win. We can maybe add a banner saying this is machine generated output, use it at your own risk, and maybe something like that if we don't want to involve humans. So that's one piece I tend definitely think could be one of the first phases to do this. Second thing you mentioned is, let's say we publish this somewhere and then the scanners will still scan things the same way they were doing before. Is there a way for the scanner to output saying, these are the CVEs you found, but for these Kubernetes ones, you should go look at this link and you will get the information there.
Yeah, I
That's
think
where
what
you're
I'm saying
coming
is
from.
that like if if we just put a document out somewhere on the website or in the repo or whatever,
Yeah.
the problems that at least that I've been seeing are that some end user is running a scanner against their production environment. There are just binaries there, and they don't. How is that tooling going to go from scanning a cluster, seeing binaries, and then know that there's a document it should read that we've published? I think if we don't have an answer to that problem, then we might wind up spending a lot of effort on this and not really improve the situation.
Yeah, I makes sense. So I see some chats as well. So let me try to answer this quickly. The answer to that was kind of use an industry standard the scanners understand, which is the Vex JSON doc that we will end up generating. So then the idea becomes like, if you use the scanner correctly, you will not get this. And if all the scanners start supporting Vex, which some of them do, then we will have less and less false positive and maintainers having to respond. So
But
Vex is
only
really the answer for this right now, but I'm open to other ideas.
that's the answer for the format, but it's not an answer for the discovery of where we publish the document. If we don't fix the
Yeah,
discovery part, then I mean that's the problem we have right now, right? These tools are not walking it back to source code and checking there where there is enough information to determine this. So like if the industry doesn't have an answer for that yet, I feel like if there's somewhere we can start that conversation, that would help us inform how we should publish them, because we want to publish it in a place that it's actually going to be read.
right. So there are a couple of options mentioned here. Uh, there is a Vex hub from, again, like Aquasec folks, which is like Docker hub, but for Vex talks. Again, like how often has that been used? What's the footprint? Maybe Aquasec folks can answer that. But that's one place I've seen people pushing Vex documents. And sometimes I've seen people push Vex documents is in OCI registries alongside the images. So which tends to work with air-gapped environments where if you have the images, you also have the Vex docs. Scanner can scan the image, it can also consume the Vex doc. And then that way it is a self-sustaining system. So those are the two current options, at least mentioned in the doc. If you have some pointers on what community could be able to solve this at a larger scale, maybe it is Golang community or somebody else, I'm happy to go chat with them.
Yeah, I don't know. I would put that back here, and I think that's probably to me one of the biggest questions we need answered to go forward on this, because that also informs what does the automation look like? Like where do we need to push to? Like if we can avoid needing to push to GitHub, then that solves some problems. But we should also bother to push it somewhere that it will help.
Yeah. And the other point about putting it in GitHub was maybe our bots framework that we have, somebody creating an issue about a CVE that already has a Vex doc in our GitHub. The bot can understand that and then auto respond saying, you should go look at this, and that maybe saves maintainer time. So that was a reasoning behind maybe we put it in GitHub, but also ship it in some other way that's easily consumable. Let me see if I answered all the chat questions.
I just want to say, I think this sounds like a fun project. It's also, I think we should do it in a way that is sort of experimental, like sort of on the side. So if it turns out that no one consumes this, we can shut it down, or that they like the whatever replaces Vex, convex, right, is the new Vex, right? That we haven't like signed up for 50 years of shipping Vex, So like a Kubernetes SIG project, I think it sounds fun. I think it would be good because it would get a broader pool of contributors, right? Because it's a little bit like like easier entry point, but it's still technical, and I think it'd be fun. And I think personally, I think we'll probably end up writing our own volume scanner, which I think would not be a terrible thing, although I'm sure everyone in this room will disagree with that. But it sounds like I would very much lean though on automation. Like I don't think we're ready to ask people to do a ton of work. I think just publishing like basically the results from GoVolCheck on our images, like figuring out what things it has actually looked at, and publishing some sort of attestation, i.e. like web page that says yes, we looked at it and this one and it's not vulnerable to this. And then then we can do all the cool things like making it easy to link to the web page when someone says, hey, are we vulnerable type thing. I think that would be awesome. I actually don't know which SIG would host it, because as I understand, SIG security does not host things, right?
We do have 3 caps in SIG security in different stages.
But you don't have any repos, is my understanding. I mean, I think that's a decision you make.
If it's a SIG, it's fine. It's the committee wouldn't own things, but now this is different. That's the SIG is different than the committee.
The charter for SRC involves not owning, or SIG security involves not owning code, but we can put it with the security response committee, or as maybe SIG architecture under the code organization subproject or something along those lines.
Okay, we're out of time, but thank you, and we'll see y'all in a couple of weeks.
All right, sounds good. Please keep adding comments. Don't be shy. I appreciate all the feedback today as well as later. Thank you.
Thank you.